Okay, yes, so welcome everybody to our big data class. If you haven't yet seen them yet, there's a couple of handouts up front up here you can come collect. But yes, this is our CSCI 143 big data course. How many people, anybody here have a class earlier than this semester? Everybody's first class of the semester. Well, welcome back to Claremont, everybody. So in this class, in our big data course, we're going to be using GitHub for a lot of things, and our course webpage here is this GitHub repository. If you've taken a course prior with me, then this will all be familiar to you. But if you haven't, that's okay. We'll go over how to use GitHub here a little bit today and what to expect from the course. And eventually we will, by the end of the day, get to a little bit of an example of what we're going to be doing with big data. Yeah, so the course webpage, I don't know if I said it out loud, it's github.com/mikeisbicky/cmc-csci143. If you would like to, you can visit that and follow along on your own laptops. In general, technology during this course, I'm happy to have you have your laptops in front of you, following along with whatever's going on the screen up here. Feel free to do whatever is going to help you. A little bit about me before we get into the details of big data. So my name is Mike Isbicky. Feel free, please, to call me Mike instead of Professor Isbicky or Dr. Isbicky. In general, so I'm a computer scientist. In the computer science world, we're a fairly informal group of people, and everybody goes by their first name. Email, office, I'll have office hour times posted later, webpage, and my main research is on machine learning. We'll see in this course that we're not going to really be talking too much about machine learning projects in this course. Instead, we're going to be talking about how you get data from wherever the data is into your machine learning project. And so we'll be talking a lot about moving data around and finding the data that you're going to need to do machine learning stuff. Some fun facts about me. I grew up in San Clemente, so that's about an hour south of Claremont on the beach. I spent 7 years in the Navy. I was a nuclear submarine officer. I have personally converted a little bit more than 10 grams of uranium into pure energy. Anytime I meet a physics professor, I always brag that they have not done that, but I have. I also worked at the National Security Agency for a little bit while I was in the Navy. At a team called that they call the Red Team that hacks into other government organizations to improve our government's electronic security. And then eventually I left the Navy as a conscientious objector, roughly feeling like the stuff that I was doing in the Navy was not making the world a better place, and ended up working on computer science in order to try to make the world a better place. Did my PhD postdoc at UC Riverside, pretty close to here, and then spent 2 years before coming here teaching in North Korea in a program to improve diplomatic relations with North Korea by having ordinary North Koreans and Americans work together on common projects. So that's about me, and let's talk a little bit about this course and what to expect from it. Hopefully the screen here is readable for everybody. I'm not sure. Maybe that's a little bit better. This picture up here that I have is a sort of a map of how I think of computer science at CMC, and especially part of the data science major, and how our class, CS 143, Big Data, fits into that picture. So at CMC, we have sort of two lower division classes, CS 40, equivalent of like CS5 at MUD or 60 at Pomona, where you go over some basic Python, and that's like the vast majority of the course. And we also talk in CS40 about some SQL, HTML, CSS, Markdown, a handful of other languages here to get you prepped for future courses. But Python's the main thing here, and you're really only working on just your one laptop by itself, solving problems that one little computer can easily handle. And then in CS46, our data structures course, we move on to not just working on your own laptop, but working on a remote server. Again, working mostly in Python, but now introducing some bash scripting, talking about Git, this thing called continuous integration, and a little bit of parallel computing on a powerful remote server. And then in this course, we're going to be expanding that even further so that instead of working just on a single remote server, you're working on potentially like a giant cluster of thousands or even millions of remote servers. And we'll be writing code that easily scales all the way from working on a laptop up to this giant cluster of remote servers. Some of the technologies that we'll be using for this are Docker containers, Postgres. Those are the main two sort of buzzword things that we'll see. But we'll also see that, I guess, some generic techniques for when you're working with Python or other languages that you've seen before, how to make them scalable into this sort of domain or situation over here. One of the cooler projects I think that we'll work on that's related to this scalability is that around week 4 in this class, you all will be implementing your own version of Instagram. And by your own version of Instagram, I mean you'll actually be using all the technologies that Instagram uses under the hood, so Docker and Postgres here in particular. And you'll have a system that can scale up to the size of Instagram. Just the scalability factor will depend on how much money you want to spend on a cloud service like Amazon Web Services, AWS, or Microsoft Azure, and what your credit card limit is. You won't need a credit card in this class, but if you want it to scale to actual millions of servers, it would be expensive. Any questions so far about anything? Okay. So a little bit more about the class. What is big data? This is kind of a funny question that depends entirely on the person who is talking. So most computer scientists, I call them muggles, think that big data is too big for Excel. And so I commonly work with, in the data science program here, we have a capstone project. And through this capstone project, students work with companies from around the world. We've done things with Disney Plus, with Wells Fargo. Those are the two big name clients that I've worked with, and then a lot of smaller clients as well. But this is by far the most common thing that those clients think of when they think of big data. That they'll basically give the students an Excel spreadsheet and say, I think I have big data here, I don't know what to do with it, and will you please move this to the cloud and spend thousands of dollars on these giant servers with these weird technologies that sound like Pokemon and make our stuff better. And so these people, again, are thinking of big data as what I think of as pretty small data, maybe like more than 10 megabytes of data or more than 1,000 rows in whatever they're working with. But if you're a computer scientist, if you're working at like one of these top tier companies like Facebook, then when you hear the phrase tens of petabytes, so a petabyte is 1,000 terabytes, which is 1,000 gigabytes. So that's a fairly large amount of data, much larger than this up here. This actually Facebook considers to be a small data problem, tens of petabytes. And we can see that if we look over here, this is a post on Facebook's research page where they talk about their open problems that they're working on. You can see up here it's from 2014, so a long time ago. Even in 2014, they said this. And when here we see the small data challenges, we can see that they have access to tens of petabytes of data listed as a small data challenge. So there's two huge extremes of what it might mean for something to be big data versus small data. And one of the biggest problems in industry, whether you are a computer scientist working at a tech company like Facebook, or a data scientist who's a total independent contractor who is working with a bunch of small companies. One of the biggest problems people encounter is that there's all of these like weird technologies, again, that sound like Pokemon, that nobody really knows what they all do or why they all exist. And like a manager hears about something like Pangool or whatever the buzzword of the day is, and they try to convert all of their data, even if it's super small data like this, into one of these new technologies. Somebody's trying to use some tool for what Facebook considers to be data, big data, like many hundreds of petabytes, into use one of those tools for what I call Muggle big data of something small like this. And so one of the things that we're going to be talking about in this course is sort of like how to avoid that trap, how to make sure that you're using the right tool for the right job. So for us, big data, again, it's going to fit somewhere between these two extremes. We're going to be thinking about things that are too big to fit in memory on a single machine. So definitely the things that we'll be working with will be too big for your individual laptops over here that you all have. We'll also be working on a remote Lambda server, we call it at CMC. The Lambda server is pretty computationally powerful, but even that, it's not going to, the data sets that we'll be working with won't fit in memory on just that machine. And so we'll see that things like distributed computing will help a lot. So using this like large cluster of remote servers to do our data analysis. The size of data sets that we'll be focusing on in this class is mostly in the like 10 gigabyte to 10 terabyte range. And so again, too big to fit in memory on most machines, but not quite the Facebook scale of things. And then the last sort of thing that we'll be talking a lot about in this class is that so this class is really designed for data science majors. Designed it so that it gives data science majors sort of an overview of basically all of the cool, interesting, fun parts of upper division computer science. So there'll be a lot of threads of very different computer science related things throughout this course, all eventually with this goal of handling this sort of data range. Since I mentioned the Lambda server here, another quick administrative note, you should have all gotten an email with login credentials to the Lambda server. If you've taken a previous course with me using the Lambda server, the login instructions are a little bit different now. For security reasons, the CMC IT people wanted to move the Lambda server behind a firewall into the VPN. And so you all will be getting instructions from the IT folk, hopefully sometime today, with access to the Lambda server, or with access to the VPN and eventually the Lambda server. Few more quick administrative stuff, and then we'll get into some fun examples here in a little bit. So who should take this course? Again, this course designed for data science majors, but I'm still very happy to have CS majors in the course. I think you'll find it fun, learn a lot of things, but know that you probably won't have fully met some of the prerequisites. That's okay. I'm confident that you all will be able to pick up whatever is needed as we go. And some of the material in this course will duplicate some of the material in the other CS courses that you've taken. This is especially true if you've taken the databases course, CS 133, but there's a handful of other courses that it overlaps with a lot as well. But I think you'll get a new perspective on things from this course. Prerequisites, background, knowledge that I'm expecting. There's three main prereqs for this class. Discrete math. This is sort of the least important prereq. I'm just hoping that you have some basic understanding of probability and how to count things, some basic graph theory, but we won't need too much of this background. The second most important course is this Foundations of Data Science course. This is the one that most CS students probably won't fully have the background from. And there's a lot of different courses here at CMC that count for this as the prerequisite. But basically, I'm hoping that you have some really basic idea of machine learning stuff, some basic SQL. We'll be covering a lot of SQL in this course. One of the things that we'll see is that SQL is going to be one of our main tools for distributing things over a cluster of machines like this. Probably in your previous courses that have used SQL, you haven't talked about how to make SQL fast or efficient. You've only talked about just like what SQL does, how to make it correct. So we'll talk about both of those things quite a bit. Another weird thing about SQL, especially from these courses, is that most of the people who teach SQL who are not computer scientists, who don't have a CS background, teach a handful of sort of shortcuts that are not technically correct about things. And so we'll be going into a lot more about the technically correct things with SQL and how to make your SQL actually do what you want it to do as well. We'll also be talking a little bit, or requiring regular expressions a little bit. Not too much about this. Whatever, if you haven't seen this before, you'll be able to pick this up pretty easily. The most important class for background for this is data structures. In particular, so the big O notation, balanced binary search trees, all courses will have covered that. You may or may not have seen some of this information before about the Unix shell commands. One of the reasons why we'll see in this course, so we'll be doing a lot of things in this course with the Unix shell, is because the Unix shell is really the only tool that exists for managing a large cluster of remote servers like this. Even Microsoft, we'll see this in a little bit, in a couple of weeks. Even Microsoft, when they are, so Microsoft Azure is their cloud service provider. On Microsoft Azure, they have more Linux machines running than they have Windows machines running. The servers that are running Microsoft.com, those are all on Linux machines, not on Windows machines. So even Microsoft believes that Unix is the better tool for really large scale systems. We'll also be talking about Git. Everybody will be very, very familiar with Vim at the end of this course. And handful of other sort of language-ish things that you'll be able to pick up if you haven't seen it before, but that do get introduced in CS40, things like Markdown, HTML, CSS. They'll all come up just a little bit in this class. There's a lot of other sort of background stuff in this README file that we'll cover as we need to. Most of it, though, is for other professors to read so that they, if you're transferring schools or going to grad school or something, we can send them this and they know what's covered in this course. So we'll pause here for now and see if anybody has any questions about anything. Okay, so we're going to do two more things today in class. The first is that we're going to just get ourselves a little bit more, I guess, background, or see how to navigate this GitHub repository a little bit, so that if you maybe are less familiar with GitHub, then you'll know how to navigate the class material. That won't take too long. And then after that, we'll get into some actual coding today and get ourselves some examples of what to expect material-wise from this class, actually seeing it happen. So the first, I guess, administrative thing about this repo, the way it's structured, is that all the topics that we'll be covering in this class, currently I have them listed here in this future folder. There's a bunch, if you were to click on that, there's a bunch of topics down here that you can see. As we get to each of these topics, I'll be moving them from this future folder into this main folder out here. But if you wanted to just get a quick overview of what to expect from the course, here it is. So we'll be covering things like MapReduce, Docker, this Instagram tech stack, which I mentioned before. So you'll actually be using all of the technologies that Instagram uses under the hood to serve their petabytes of data a day to all of their millions of users around the world. A lot about SQL in this course, and everything from topic 6 down to topic 11 down here is essentially different ways of how to make SQL code fast. So a lot of things that, even if you've taken a databases course before, this stuff down here is very likely to be new because database courses often focus more on theory things, and we'll be focusing really on the practical aspects of working with data. If you've taken not the machine learning course, but the data mining course with me, that was a very math-heavy course. We basically won't be having any math in this course. There'll never be homework assignments where you have to do a math problem or prove anything or anything like that. It's all going to be coding assignments throughout this course. Very similar in structure to how CS46 was. So back over here inside of our first topic, the stuff we'll be covering this week, it'll be some background on Unix. This will be mostly review for people who've taken CS46, but there'll be a handful of new things here sprinkled in to also help keep things interesting. Up here at the top of our topic folders, there's always going to be some links to, these are called submodules in Git that contain all of our assignments for the week. And then the README file down here will contain whatever lecture notes or material that we'll be covering in class. The first thing I want to highlight is that if we scroll down all the way to the bottom here of our topic 0 folder, then there's going to be, or there are details of a lab and a homework assignment. So in this class, we'll have our normal lectures on Tuesday and Thursday, and then Friday break out into labs. And not always, but in the first couple weeks here, we'll have some pre-lab work for each of these labs. And this will just help ensure that everybody's on the same page about background material so that the labs are more productive. So before Friday in this class, you'll want to complete all of these pre-lab sort of assignments right here. Then down here, there's a section on homework, and there's also some background work for the homework, and there's these tasks to complete as well. You don't have to complete these before Friday's lab, but I do recommend getting started on these before Friday's lab so that if you do run into questions about things that you're maybe not familiar with or that weren't covered in previous courses for you, that you'll be able to get those questions answered during lab. So again, summary, before Friday, definitely make sure you've completed the pre-lab work under this lab section in the topic 0 folder of our course repository. And you don't have to have this background work completed under the homework, but you should at least have that started. Questions at all about what you need to do for the lab period before Friday? Things to get started with? Okay. One last note about that. Under the homework background work, you will need to have Lambda server access to start on this. But in order to start on the pre-lab work, you don't need to have Lambda server access, so you could start on that immediately. We'll also be having regular quizzes. Question? No question. Okay, we'll be having regular quizzes in this class. The quizzes will be basically every week on Thursdays, and there'll be no quiz this Thursday, so no quiz next class period. First quiz will be next week on next Thursday, and we'll be going over the practice quiz material here in more detail, but there's 2 handouts up front, this POSIX Shell 2 and POSIX Shell 1. Quiz practice stuff that will be what the quiz material will go over. And again, we'll go over that over the next couple days. Question? If that's a typo, the quiz will be on the 25th of January. So yeah, next Thursday, 10-ish days from today. So speaking of typos in this course, one of the reasons why I like doing classes on GitHub is because I am a puny human. I make mistakes. I am not a computer who is perfect at everything they do. And so throughout this course notes and assignments, there will be a handful of typos like this where I have made a mistake. And the nice thing about GitHub is we have a tool that allows people to collaborate and correct other people's mistakes or contribute clarifications or whatever other things people might want to contribute. We'll go over how to do this later in this course in a couple days. But if you were to submit a pull request to this repository, making a correction, fixing a mistake that I've made, then you can get extra credit in this course. I guess speaking of that, you can see on our main class repository up here, there's this contributors section over here, and you can see that a number of former students have made various contributions to this course, correcting things that mistakes or things that I've done incorrectly, and you could get added to that list and get extra credits. One of the pre-lab materials or pre-lab tasks that is a particularly important one, let's go back over here to our topic, come back down to our pre-lab work here, is this task 2 here where it says press the watch button at the top of this page. What that's going to do, if you at the top of this page, what is it? I don't even know which button it is. There's a watch button at the top of this page. It's a little bit different for mine because I'm the owner of this account. And if you click that, then every time an issue is posted over here on our project, you'll get an email about that issue. And this will be the main way that we'll be communicating about things through this course. Anytime I have an announcement to give you all, I will be posting an issue here. And anytime you all have a question about how to, whatever the question is, you can post the issue here, and I will respond to it through GitHub. 2 reasons why I like using GitHub to communicate with students in my courses are, the first one is that basically everything in my courses I want to be getting you all prepared for your future jobs and careers, whatever they may be. And when you graduate from here and go on to your excellent career in whatever field you choose to do, I guarantee you will never use Sakai again. And so whatever workflows and habits you develop with Sakai, it's all just a waste of time because when you graduate, that's all going away. But GitHub will not go away. That if you have any sort of career in any field remotely related to computer science or data science, you will be using Git and GitHub throughout your entire career. And I want you to be getting practice with how to use these tools and develop good workflows. I also want you to be building up sort of a GitHub portfolio where you may have heard that recruiters like to look at people's GitHub profiles. They actually have tools that they can just run on somebody's username, and it'll count things like how many issues has that person posted to how many different repositories. And my classes are designed a little bit to game that system so that you all get a lot of extra things posted to your GitHub accounts, making you look even better than you already are to those recruiters. So that's one reason. The other reason is more practical from an education standpoint, that if you have a question about what a certain technology is doing or why you're having a certain error, if you post it to GitHub, then other students in the class maybe will see it before I do and can answer it very quickly, and you'll get faster feedback that way. Or if I go in and answer it, then everybody will be able to see the question and answer and benefit from it, not just one student. So all communication through GitHub in this class. Almost done with boring administrative stuff. Last thing about quizzes, bouncing back and forth a little bit here. So all the quizzes in this class will be open notes, and so I strongly encourage you, as we're going over things, the reason that I provide printed out versions of these practice quizzes so that you can take notes on them as we go over them in class, and you'll have those available during the quizzes. Usually students tend to do very well on quizzes, and it's not like a high stress sort of thing. Okay, any questions about anything at all so far administrative? Okay, then let's go into start doing some interesting big data coding stuff, see some examples of the kinds of things that we will be doing in this class. The first thing is I want to just point us here, take a look at the lab that we're going to be completing this week. I'm following this link down here over to this webpage. And in this lab that you'll be completing this week, we're going to be writing AI review summaries of products. So you may have noticed that Amazon recently launched this new service where AI models like ChatGPT are summarizing product reviews, and they're putting those summaries on their website. So as an example, here's an AI-generated review for this package of uranium ore, which is a real product here on Amazon that you can purchase. Did not mean to click that link. So it says here, the customers are saying that they like the performance, quality, and delivery of the uranium ore. They mentioned that it works well, is a good tester for any Geiger counter, and is an awesome little natural product, and so on. And so no human wrote this, this sort of summary of reviews. This was an AI product, probably ChatGPT, that combined a bunch of human reviews together into this sort of summary. And in your first lab this week, again, we'll be reviewing a bunch of the Unix shell tools in order to do something like this. At the end of the lab, you'll have your own system that does this. In order to do this, we'll be using a data set from this website, goodreads.com. It's a public data set, contains all the activity on Goodreads from 2006 when it was founded up to 2017, so about 10 years. It's approximately 30 gigabytes of data, 15.7 million user reviews, 2.3 million books. So again, this is sort of the very typical of the type size of data that we'll be looking at in this class. And what we'll see is the hard thing about this is not using the AI in any way, not using ChatGPT, or actually we'll be using a model called Mistral in this project. That's going to be totally easy, straightforward. That's like a 30-second one-line thing to do. The hard part is going to be actually finding the reviews, finding whatever data we need in all of this data, and extracting that and getting that to the AI system. And we'll be using Unix, the Unix shell to do that. So now I'm going to jump over here to the screen and get started with some examples of the first sort of steps in that process so you can see what to expect as you're doing it. In this class, we're going to be working, doing a lot of live coding in this course. And right now, what I have open on my screen, I have two terminal windows that are already connected to the Lambda server. Usually in this course, while we're doing live coding stuff, most students like to follow along with what I'm doing. You won't be able to follow along right now because you don't have access to the Lambda server. That's okay. The goal of right now is just to get sort of a sense about what to expect from throughout this course. I'll pause here and ask a question. How many people feel super confident with the command line, Unix command line? Very few people? Okay, that's okay. Yeah, so again, even people, if you've taken CS46 with me, you've been exposed to it, maybe you don't feel super comfortable, it's been a long time, you've forgotten things, or maybe even at the time, you just didn't feel comfortable with things. We'll be spending the first 2 weeks or so in this class reviewing all of that material so that you will get comfortable with it. And then the remainder of this course using the Unix command line to do cool things. So the first most important thing, most important command about the Unix command line is the ls command. I'm going to go over here some of these basic commands, maybe remind you about how to use the command line here. and then we'll do our little data analysis project. Here, when you first log into the Lambda server, you're in what's called your home folder, and your home folder will start empty, except that it'll have this little folder inside of it called Big Data. Normally, or inside of this Big Data folder, you have 256 gigabytes of space that you're allowed to use. Outside of this Big Data folder, you have 10 gigabytes of space that you're allowed to use. So those constraints are designed to force you to make sure that you're using the right techniques about different things, and the labs will walk you through, make sure you're doing the different things in the right place. But in this case, I'm gonna go inside the Big Data folder here. The CD command, that's for change directory, will take me into the folder that I'm looking at. And I have this file here, goodreads_interactions.csv in this file. This file is one of several files that you'll be using in this lab to make this AI program. And a good first step anytime you're working on a project is to see how big the files are that you're working with. And on the command line, there's a command DU, stands for disk usage, -H for human readable, that lets you do this. And if we do that, we'll see that this file right here is 4.1 gigabytes. So there's a handful of other files as well that altogether add up to that 30 gigabytes, but this one file alone is 4.1 gigabytes. And what we're going to do is we're going to write some Python code that is going to do some super basic data exploration of this file. And we'll see that the Python code that maybe you're used to writing, some of the techniques that you're used to using, aren't going to work well, and so other techniques will be called for. Down here, so I have, again, two terminal windows open. In the top window up here, I've already moved to the Big Data folder. These two windows, though, are totally independent of each other. And down here, you can see that I'm not inside of the Big Data folder. I'm still inside of my home folder down here. And so I'll move this one down into my Big Data folder as well. And now they're both in the same location. If the command line stuff is confusing or maybe totally lost at this point, that's okay. Again, the first lab is going to walk you through all the steps that you need to do in order to do the data analysis, get you familiar with using the Lambda server and the shell here. And we'll be covering all this material again in the next couple of days in class. But at this point, any questions about just the setup of the environment, what's going on here? Yes. Yeah, question is that I have the credentials to the Lambda server, but I don't have the CMC VPN account yet. And I don't think anybody has the CMC VPN account yet. The IT folk are being a little bit slow on getting those instructions emailed out to everybody and getting the accounts. Hopefully they will have that today. But yes, so because of that, you won't be able to log in and follow along exactly with what I'm doing here. But again, the point of this exercise that we're going to do here is just to get us a sense of what to expect from the course, rather than maybe to learn something concrete. So I apologize for that. One of the things that is one of the awkward tools, or tools that most people will find awkward, that we will be using a lot through this course, is the Vim command. Vim is a text editor designed for working in the terminal here on remote machines. And so if you type Vim and then the name of a file, example.py like this brings you into a new window where you can edit things about the files. So something like print hello world, and I type ls, and now there's this example.py file here that's been created by this Vim text editor. I'm going to switch back over to our class notes for topic 0 here for a second, because there's a little section down here on Vim. So we've already talked a little bit about this map of CS at CMC. And this next line down here says that you're going to have to, in this class, all of your text editing must be done in this Vim command, this terminal text editor. Many people find Vim to be very confusing at first. It has a very steep learning curve. So this is a sort of famous graph that describes the way that people think of Vim, that your productivity here is on the y-axis, how much time you spent using a tool is on the x-axis. So this red line here, a general IDE might be something like VS Code, where it's relatively easy to learn, but it's maybe not as powerful. So after you've been spending some time using it, you come up to a wall where there are things that you can't do. Vim, though, is extremely powerful, and so it takes a long time to learn and get comfortable with. Most students will spend probably the first month of the course or so hating me because I'm making you use Vim. But then after you're comfortable with it, there's a lot of things that you can do with Vim that you can't do with other text editors. One of those things is that Vim is very easy to use, not just on your laptop or on a remote server, but inside of like arbitrarily far away clusters of remote servers. This is something that is going to be impossible to do with VS Code. You may have used VS Code previously to connect to a remote server and do stuff on a remote server with VS Code, but we will encounter a lot of situations in this class where you're not just connecting to a remote server, but connecting to a series of many remote servers, and that's just not possible to do with VS Code. You'll have to use a tool like Vim in order to do that. So the main motivation for why we're using Vim is to be able to do things that things like VS Code cannot do. Vim is also super powerful and as just a plain old text editor, and you'll hopefully by the end of this course be very comfortable with Vim and maybe even like it for normal text editing more than VS Code. One of your pre-homework assignments, background works, is running a command called Vim Tutor in the Lambda server like this. And Vim Tutor is a tutorial that walks you through the basics of how to use Vim. Again, complicated, different than what you expect in many ways. And so it'll probably take you about a half hour or an hour or so to work through this tutorial. At this point, the most important thing is that if you are inside of Vim, pressing escape, or maybe you've tried doing Control-C before to exit things, that will not leave Vim for you. If you want to leave Vim, it's :Q will take you out of Vim. But again, the tutorial will walk you through those things. So back to our task at hand is we're trying to understand some basic information about this Goodreads_interactions.csv file. And the first, maybe simplest thing that we might want to understand after the size of the file is how many lines are inside of this file. That how many lines corresponds to how many data points are in this CSV file. And if you've used Python before, then here's a very simple Python program which will complete that task for us. So first, open the file up here. Say that the text of this file is f.read. So f.read just actually takes whatever the contents of this file are and puts it inside this variable over here. And then if we want to get the number of lines here, we can use a command that looks something like lines equals text.split on \n. Again, the \n here is the character that represents the new line in a text document. The split command in Python will find all of these strings and convert them into their own separate substrings. And so this variable right here will contain all of the lines inside the document. And then we can print out the length of lines. Length of lines equals length of lines, like that. Down here, I'm going to run this command with Python in the terminal, the way we run our files that we've written. Real quick, I'll run ls again down here. You can see that the example.py file has been created. We do something like Python 3, and then the name of the file like this, and it'll run that file. And because it's a relatively large file here, this will take a little bit of time to complete. Any questions while that's running about just what this Python code is doing? This Python makes sense? Again, the purpose of this is just to count how many lines are in the file. So this right here is loading the file, then we're computing or actually creating the lines right here with the split command, and then counting the number of lines down here. And when we run this file down here, we can see that our code is actually not successfully completing. I'm getting this memory error down here. What memory error means is that I've run out of memory on my machine. On the Lambda server, I'm going to go back to my notes up here. We'll talk a little bit more about the Lambda server. The Lambda server is a pretty powerful machine. It has 80 processors, 8 GPUs, and 256 gigabytes of RAM available to it. And you get a memory error like this anytime that you have run out of memory, that you are not able to load up this file into memory. In this case, we've seen that this file was 4 gigabytes of RAM. And it turns out that when you load a CSV file into Python, it takes up a bunch of extra overhead space. And so it's really not just 4 gigabytes that's loading up, it's a little bit more than that. Still though, it's not going to add up to 256 gigabytes. Your accounts have a number of limitations on them. One of those limitations of your accounts, so one limitation of your accounts is that you can use only 16 gigabytes of RAM at a time. And actually, when we load this up, this piece of code up here, even though we're only loading a 4 gigabyte file, is using more than 16 gigabytes of RAM, and so that's why we're getting this memory error down here. So one of the things that we'll be doing in this course is figuring out how do we write code, whether it's Python or any other language, how do we write code that is going to not give us an error like this, not give us a memory error. Any questions so far? Write code, our goal. Write code that does not give memory error. And to do that, anytime we're working with big data, really, one of the big requirements that we're going to have, our code must use constant memory. So we want to be writing code that is going to use the same amount of memory no matter how much data we're loading in. Here that we have a 4 gigabyte file, probably we could have a machine that could load this up in memory and run this code just fine. But if we have a 10 terabyte file, there's really no machines that we can just load that up into memory. And so we'll always want to be get into the habit, the practice of writing code with just constant memory. In this case, there's two lines here that are using linear memory, working with all of the data at once. This line 2, reading all the data at once. That's something that we're going to avoid in this class. And then this splitting here is also going to be creating a list with all of the data in it at once. So our new technique is going to be, in Python, looks something like this: for line in F, num lines equals 0, num lines plus equals 1, and then print num lines equals num lines. So here, this code's a little bit more verbose than the code that we had up at the top up here. But this for loop now with for line in F is only going to load one individual line at a time in our file. And so we're not going to have to load the entire data set, and we'll be able to actually complete this task. If I save this in Vim, that's :W, come down here. One of the things that I'll be doing a lot in this class is sort of thinking out loud about all of the different things I'm doing in the terminal, different shortcuts or other things that I'm doing. And one of the very common shortcuts that I do in the terminal is I use the up arrow to go back to previous commands. And so I press the up arrow twice down here in the bottom terminal to go up to my Python 3 example.py command. So I don't have to rerun that or retype it. And then I hit enter and rerun it. And hopefully now we'll get an answer printed out that does not encounter this memory error problem. You'll notice that this code is still taking a long time to run. It'll take like half a minute or so, but at least it'll run and it'll give us a good output. While that's running, any questions about anything so far? High-level ideas? Yes?
So when you do
question is, right here on line 3, when I say text equals f.read, how much memory is actually being used? Turns out that this line right here is going to allocate basically one byte per byte in the file. So this is only going to be this is a 4.1 gigabyte memory usage. So use the Python comments. This line down here is using the rest of the memory. This is a greater than 12 gigabyte memory usage line. And one of the downsides of Python is that it's very difficult to predict exactly how much memory usage different tools are going to use. It's much easier to predict the asymptotics about how much memory is going to use here. But you can see there's a big explosion from 4 to at least 12 gigabytes here. And I know this has to be at least 12 gigabytes because we have 16 gigabytes allocated to us and we're getting overflowing how much we have available. So this is the main source of that extra overhead. Did that answer your question? Cool. And now down here on the bottom, you can see that our Python 3 example.py has finally completed. And so we have this really large number of lines being output down here. So 3 grouping this. So 228 million lines being outputted. 228 million lines. In the shell and the terminal, comments are done with hashtags, hashes, pound symbols. The same way they're done with Python. So commonly, I will write some comments like this inside of the shell just to maybe clarify the output of previous things or clarify things that I'm saying in class here. So there's a fairly large CSV file here, both in terms of file size and in terms of the number of lines. And it turns out what this CSV file is storing for us is basically every time a user in the webpage goodreads.com clicked a button on the webpage. So that's what they mean by interactions here, is that the user interacted with the webpage. So 228 million button clicks that are being stored in the CSV file. So that's great that we now are actually able to count this, but it's still a relatively slow process, slow command. And a faster command is to use a faster tool is to use some built-in commands to the terminal down here. And the tool that we'll see right now is the wc-l command. What this stands for, wc equals word count, -l equals the number of lines. And so if I type wc-l and then the name of a file, it's going to tell me the number of lines in that file. So this wc-l is sort of a built-in way for doing this Python code that we have up here. And I'll hit enter, and you'll see that in just a second or two, we get the output down here with all of the same exact number down here. So this built-in shell command ran in just 2 or 3 seconds, and this Python code up here ran in 30-ish seconds. So about 10 times faster for this command down here. So again, one of the reasons we'll be spending a lot of time in this class on the shell in this terminal is because shell commands are extremely efficient. So they're going to be both asymptotically, maybe I spelled that right, maybe not, asymptotically correct. In this case, O of in compute, O of 1 memory. And they're going to have excellent constant factors, much better than anything you could write in Python. And so we're going to explore these shell tools, get very familiar with them so that we can use them to do our data analysis very efficiently. Any questions about that? Yes. Great question. So the question here is, what's the asymptotic complexity of this Python code that we have down here? We talked a little bit about it of this code, but maybe I glossed over it down here. This for loop down here, this is sort of a Python idiom that you just have to know in order to do this correctly. So it's okay if you've never seen this before. But this type of for loop is going to have O of in runtime, where in is the number of lines in file. Because we're looping over every line in the file, this F again is the file descriptor from created right up here. F is the file descriptor, and if you loop in Python over a file descriptor, you get you're looping over the lines. So our runtime is linear in the number of lines, but it also has the nice property that it is O of 1 memory usage. And so it doesn't matter how much how big the file is, this will take constant memory usage independent of the number of lines. Did that answer the question? So the question is, why does line 6 up here not take up a whole bunch of memory? That if we're opening this file, then if it's a really large file, why does that not take up a large amount of space? Turns out that in Python and in the vast majority of programming languages, anytime you use any command to open a file, so in this case, the open function, doesn't actually load the memory into, or load the file into memory. Instead, what it does, the open function registers something called a file descriptor with the operating system. And the file descriptor just tells the operating system that at some point in the future, I'm going to be accessing this file. So this tells the OS that at some point in the future, I'll access this file. But it doesn't actually do the access at all yet. So this always has O of 1 runtime and O of 1 memory usage in any language when you open the file. And it's the file operations here looping over the file, or in our first example up here, the reading and the splitting. These are the things that actually take the memory usage or the runtime. Yeah, great questions. If that all seems a little bit fuzzy, that's okay at this point. Again, the point here, the thing to be taking away is that in Python, running efficient code at large scale is maybe not obvious how to do it, and it's slower than doing it in Bash or in the shell. But if we use the shell, if we use built-in shell operations, then we're going to get essentially the best possible compute times, linear compute, and constant memory usage. Let's see. Any other questions at this point? Yes. Yeah, it's a great question. So here we've started talking about there's some trade-offs between these two languages of the shell versus Python. And the question is part of this class knowing when to use those, which language for which task? And the answer is yes, but for the vast majority of this class, you will be doing everything, or I will be telling you which language to do what thing in order to get you practice with using techniques. Then the very last portion of this class, so I'm going to jump back over to our course webpage here and talk a little bit about grading in this class. In the very last portion of this class, you'll have to make some of those decisions for yourself. So in this class, grade-wise, again, we'll have sort of these weekly labs, weekly quizzes. We'll also have weekly homeworks, 2 exams. All of this material, basically, I will be telling you what tool to use for what task. Then the very last task in this class, for those of you who are not graduating students this semester, you'll be completing a final project where you'll have to basically make those decisions for yourself, implementing some sort of large-scale data analysis project. But yeah, great question. Some last minute administrative notes here. So textbook, no textbook in this course. All sort of material about big data is very rapidly changing. And so there are some textbooks that exist, but they're already out of date. And so we won't be using them. Instead, we'll be relying on entirely electronic resources for things. Again, these links here are mainly so that other professors know what we used. As we go into each of those topics, I will have links to the particular web pages that serve as the textbook for each of those topics. For our first topic, it's the labs and the homework background material. The reading inside of those are the textbook for our topic. Our late work policy is that everything in this class, again, is designed to get you lots of practice with computer science concepts, even down to our grading policy, that everything is going to be a power of 2 in this class when it comes to grading, to get you intuitively familiar with these important numbers in computer science. And so our late work policy is that you'll lose 2 to the I points on every assignment, where I is the number of days late. And yeah, that's all I want to say about that for now. I think this is a good stopping point for us today. Hopefully next class everybody will have access to the Lambda server, and so we can start going over the quiz material and the POSIX shell, and you'll be able to follow along with what we're doing in class. If anybody has questions about things in the class that you feel are more personal, that you want to talk about with me one-on-one, I'll hang out after class here to talk with you all about that. Or if you don't have the email from me about your Lambda server credentials, then I can get you an account on the Lambda server right now as well. It's great seeing you all today, especially all the familiar faces that I've seen before, and look forward to seeing you all the rest of the semester. So is our official end now when I stop our